So, let us recollect what we have done up till now. So, we have considered regular curves whose equation in natural parameter is written like this, and if I assume that it has component x, y, z, then you can also write it x s, y s and z s. The derivative of r with respect to s is always denoted by the symbol r dash, and it is in fact the tangent vector whose components are x dash s, y dash s, z dash s. So, this is in fact a unit tangent to the curve. And this we usually denote by the symbol t bar. And there are other unit vectors associated to the curve C. They are denoted by the symbol t, n and b. This triplet of 3 unit vectors which are orthogonal to each other are also known as Frenet trihedron. So, this is a Frenet trihedron which is always available on a regular curve. These vectors are, this first one is unit tangent, I already have written down, and the second one is called the principal normal, and principal normal is given by r double dash upon modulus of r double dash. The binormal is orthogonal to t and n both. So, B is given by t cross n, and these 3 vectors form a right handed system. So, if you want to express in terms of derivative of r, it will be r dash cross r double dash upon modulus of r double dash. So, and since they form a right handed system, we have t equal to n cross b, n equal to b cross t, and b we have already written is t cross n. And these 3 vectors in fact are moving vectors. So, along the curve you have a system of 3 vectors which are moving with the curve. Their magnitude will remain 1, but their direction changes along the curve. So, whenever I say Frenet trihedron, I mean the moving triplet of 3 vectors t, n and b. Then the second thing that I discussed with you was the osculating plane. This plane by definition is the plane which has the highest order of contact. It has a contact of order at least 2 with the curve at a point P. So, this is the plane whose equation we worked out at a point r as 0, and this is dot B equal to 0. B is the unit normal. Everything is computed at a point whose position, whose parametric value is s 0, but we do not mention all the time. So, B is also considered at a point r is 0. So, this is the equation, or you, if you like, you can also write down r minus r 0 and this dot product r dash 0, r double dash at 0 equal to 0. Or we have another notation, this is a scalar triple product of 3 vectors which we usually denote by bracket. So, bracket r minus r 0, r 0 dash, r 0 double dash equal to 0. And once we have this plane which is orthogonal to B, we can think of two more planes, one perpendicular to T and the other perpendicular to N. We call them normal plane and rectifying plane respectively. So, but this is the most important plane to us. And the third thing that I have discussed with you is the curvature and torsion. Curvature and torsion are the two geometric invariants of the curve. They are such an important quantities that they determine the curve. If you know curvature and torsion as functions, you know the curve. So, in fact, this is the fundamental theorem of curves, but we will discuss this theorem little later. So, the next two ideas, let me write down here itself the notion of curvature. Okay, let me write. So, the third thing, this is the first thing, and then ferrite trihedron number 2, and then osculating plane and the other planes, this was number 3, and number 4 I discussed with you the curvature K and torsion tau. Of a regular curve. We defined what these quantities are and we found their formulas. So, all the time I am assuming that the curve C is a regular curve with this equation. So, if you compute their curvature, the curvature turns out to be the rate of change of the unit tangent T. You can write down this also as r double dash, because T is r dash. And if you are working with generalized parameters, so you can have a corresponding formula in generalized parameter. So, in generalized parameter, the curvature K is given by the formula mod of r dot cross r double dot upon mod r dot cube. And similarly, torsion is the change in the binormal. So, by definition, torsion is the absolute value of the rate of change in the binormal when you move along the curve. Geometrically, if you want to see what torsion determines, it actually determines the tendency of the curve to go out of its osculating plane. And when you see its expression, so this is the expression in natural parameter, in generalized parameter. We made certain other observations which were important. For example, the vector B and the change in B occurs along the principal normal. So, and the component is tau. All right. So, these are important observation, and then come to the formula of torsion in generalized parameter. So, in generalized parameter, okay, bhai.